Considering the SN curve of figure 9.27 for an aluminum bar, we will find the moment amplitude MA, which will cause failure in 10 to the power of 5 cycles. We know that the bar is subjected to a mean bending moment of 5 Newton meters. In part A, we will use the equation 10.21, which is modified Goodman, and in part B, we will use equation 10.27, which is SWT. We can start by writing the information we got from the figures. From figure 8.12, part C, we know that the nominal stress S will be equal to 32 m over pi d1 cube. From figure 9.27, we can say that the D diameter will be equal to 7.62 millimeters and it will be equal to d1. Furthermore, for 10 to the power of 5 cycles, the nominal stress amplitude will be equal to 220 MPa. The mean nominal stress will be equal to 32 times the mean bending moment over pi d1 cube. And it is equal to 32 times 5 Newton meters over pi times 7.62 millimeters cube. So that Sm will be equal to 115.11 MPa. So we can start with part A. According to modified Goodman model, we know that the SAR will be equal to SA over 1 minus KFM times the mean nominal stress over sigma u. We have the data to calculate this equation. SA over 1 minus KFM will be 1 since the material is ductile. And we know that Sm is equal to 115.11 and sigma u is equal to 476 MPa from table 9.1. So that the nominal stress amplitude will be equal to 166.8 MPa. Since SA is equal to 32 MA over pi d1 cube, MA will be equal to 7.25 Newton meters. When we make our computations according to SWT equation, we can say that SIR will be equal to Smax times SA, and we know that Smax is equal to SA plus Sm and times SA, so that 220 MPa will be equal to the square root of 115.11 MPa plus SA times SA. And when we compute, we will see that SA is equal to 169.85 MPa Again, we know that SA is equal to 32 MA over pi D1 cube, which will give MA is equal to 7.38 Newton meters.